Water is the element that makes life possible. Nevertheless, we tend to forget that a reliable supply of clean water for all our needs is not automatic. It's actually the product of a complex chain of operations. Agriculture also needs a vast quantity of water. Irrigating fields in southern European regions is a daily necessity, and in every region, dry or wet, the use of water has to be carefully managed to grow crops successfully. Finally, all ecosystems are dependent on water. The circulation of water in the form of liquid and vapor from the planet's surface into the atmosphere and back to Earth is called the water cycle. Only 1% of Earth's water is drinkable, and the increasing demand on water at different stages of the cycle for hydropower, industry, tourism and households, in addition to agriculture, means careful management and usage is vital. The Group on Earth Observations, the GEO, aims at making available accurate global information to track water's changing courses, which is very important for its sustainable use. In this context, the Sirius project is developing satellite-assisted services for efficient resource management to achieve sustainable food production in water-scarce environments. The enormous risks deriving from mismanagement of water create the need for planning based on accurate information available only through sophisticated models operating on continuous observations. And this is exactly what GEO is setting out to do, to establish a global Earth observation system of systems capable of tracking vital resources such as water.
GEOS is aiming at providing all necessary Earth observation data for free. And because sharing is an important prerequisite actually to run global models, for example, that utilize data from different parts of the world. So you need to standardize the data, or the data needs to be in a usable format, and that is not really a trivial task.
It's clear that water supply has become a global problem, and so it's best managed globally. GEO is encouraging this approach through the exchange and sharing of observations and knowledge all over the world.
Satellite observation techniques are becoming more and more important. They are useful, for example, to close data gaps in data-scarce regions of the world. They can provide important additional information to your ground-based observations. The challenge really is the combination of the two observation types, actually.
It's well known to scientists that space data needs to be underpinned with standardized ground observations. In the Italian Alps, the CLIMB project collects water data through a network of meteorological and gauging stations and other in-situ observations to support sustainable management of resources. But most observations are managed by different groups with different interests, whereas the challenge requires coherent global data. GEO encourages standardization and interoperability across groups and disciplines, helping to build global data sets. Water-related disasters are increasingly frequent in many parts of the world. We need early warning systems before they happen and accurate information to organize effective rescue and recovery operations afterwards. The future of GEO is now part of an ongoing process because the water communities are convinced that the sustainable future envisioned in the Rio+20 debate will need GEO to observe, share and inform, and to continue the voyage in the blue.